All right. Okay, I think I have everything all hooked up. I just got a nice little notification from LinkedIn that we're live that I clicked on. So I found the link there. I'm just going to share it with my panelists here and my co-host, Rob, so we can make sure to answer everyone's questions. But welcome if you're joining us. This is always important to mute the other live streams when you're talking. Okay, cool. I'm just sharing the link. If you're here joining us, welcome on YouTube and LinkedIn. This is a University Alliance member panel of lightning talks. So it's all about learning how professors in the program are using and teaching Databricks. So I'm just going to share a few links internally so we can make sure all your questions are answered, and then I'll go ahead and get started. All right. Okay, I think everything's good. I think we can go ahead and get started. So I'm going to share my screen. All right, so welcome everyone. You're here for an online meetup through the Data and AI online meetup group. And today we have a couple lightning talks from professors at Bryant University, Harvard University, and Maryville University. So, and we also have the program manager from this community program, Rob. So to all learn about how they teach and share Databricks with their students. So I wanted to give a quick call out. This is part of our Data and AI online meetup group. So I'll drop the link in the chat on YouTube and LinkedIn. If we'd love to have you join us, that's where for the next couple of weeks at least, you'll be notified of upcoming sessions that we have and all the awesome content we have. And then also too, all the recordings live on our YouTube playlist. So we have all of our tech talks and online meetups and AMA sessions. So I'll also drop the link to that playlist. And this session is recorded and it'll be available immediately after. So you can revisit or share as you wish. And we also do our best to moderate the comments on YouTube and there. So if you do have any questions or follow-up things, we do try to monitor that and answer them as we can. So feel free to ask questions if you have them at a later date. And then, so super exciting, last week, so we have our conference coming up, the Data and AI Summit, and it's a hybrid this year. So in person in San Francisco and online if you'd like to attend online, and that's late June. And we just announced the summit agenda. So we have tons of awesome content, all centered around building the modern data stack in the data lakehouse. So lots of great sessions. We have some lightning talks and AMA sessions. I think there's going to be a live podcast stream with some of my other colleagues. So lots of awesome content. Hope you'll check that out and join us in person in San Francisco or virtually. All right, so without further ado, I'm going to pass it over to Rob to give just a quick introduction on the program and all the awesome things that he's doing in his community space, and then kick off the lightning talks. Rob, take it away.
I really don't do anything awesome. It's the people listening and the people who are about to speak. So my primary role is to find resources and get them in front of faculty members and students. So at the end of the day, I'm happy when it's easier to teach students and the students who are learning learn a novel skill set that helps them get a better job. That's pretty much it. Numbers wise, it's always helpful to sort of ground me in the reality of, is the program successful? Does it have a critical mass? And again, it's not about Databricks, the company, but about, can you learn from your peers and find good resources for teaching large scale analytics without having to spin up your own Hadoop cluster? Right now, the program has about 350 schools, about half of them in the US, about a third in EMEA, and the remainder in Asia Pacific and Latin America. And I'm just that some people email me once in a while and say, this is really useful, thank you. That's what's most important. So with that alphabetical by last name, I will pass it over to Mr. Robbie Bean.
Well, thank you. So first, thanks to Karen and Rob for setting this up and for inviting us to give this talk. I'll go ahead and share my screen. Let's see. Okay. So you should be.
Sorry. One thing I forgot to mention. If you want to tell us where you're watching from, that's always nice to sort of see where people are tuning in from. And we did put it later in the evening Pacific time so that this is more friendly to the Asia Pacific audience instead of being at 1 a.m. So I'm sorry, go ahead, Robbie.
All right. So are you able to see a Canvas course currently? Okay, excellent.
Yep.
So hello, my name is Robbie Bean. I am an assistant professor of data science and program director for the computer science program at Maryville University in St. Louis, Missouri. And today I'm going to discuss the big data analytics course that I developed at Maryville and how I make use of Databricks in that course. I'll talk a tiny bit about the content that I cover in that course, but primarily I want to talk about how I manage my course within Databricks. This is going to be targeting anybody who is considering using Databricks within a course, and this can show you maybe one version of what that might look like. So to give you a brief overview of the course, it is an 8-week online course. Well, it's offered in online and on-ground formats, both at the graduate and undergraduate level. And the version I'm showing you here is the online graduate version of the course, which is an 8-week course. The course covers general concepts relating to distributed data analysis, and it uses specifically Apache Spark and PySpark to demonstrate these ideas. Some of the specific topics discussed in the course would be sort of an introduction to Spark and distributed data analysis. We begin with a little bit of a discussion. We spend a little bit of time talking about RDDs, or resilient distributed data sets. Then we move on to talk about data frames, discuss concepts like joins, Spark SQL, things of that nature. We spend about 3 weeks with a little bit of an introduction to machine learning. We don't go real deep into it, but we do talk about a few different linear models and tree-based models. And in the final week, we spend a little bit of time discussing structured streaming. So the students, of course, have access to a Canvas shell that contains course content. And I don't want to spend a lot of time on that, but just to show you just real briefly, each week there's a module associated with each week that has sort of an overview, a list of the assignments, and a few lessons. For each of these lessons, there's some videos as well as just some general reference content. But at the top of every lesson in Canvas is a link to a Databricks notebook. And I strongly encourage students from the beginning of the course to primarily engage with the material through Databricks, where they can actively execute their code and those sorts of things. And I'll show you what that looks like in just a second. Okay, so you should see a Databricks deployment now for a section of my course. And so I'll show you a little bit of just how I lay this out. Actually, I guess I'll say one of the benefits, I found a number of benefits to using Databricks in this course. To list a couple, it gives me a no installation way of a no installation platform that can very quickly allow students the opportunity to kind of get up and running and engaging with the material without having a lot of sort of technical hurdles that they have to overcome before they can start working. I also find that it really serves well as an alternate learning management system. And that's really largely what I'm going to kind of demonstrate to you today, like how I use it just for grading and distributing content and things like that. I've been really quite impressed with how well suited it is for those sorts of tasks. So all of the content in the course can be found, students are able to find it under this workspace tab. And when a student logs in for the first time, they're going to see a user folder and like a lessons folder. These other folders are going to be available to instructors. Most of them will be available to instructors, but not to students. So for example, I will have like a folder for homework solutions or project solutions that are available to instructors, but not to students. So the lessons in the course are, for every lesson in the course, there is both a Canvas page and a Databricks notebook. I'll show you just a couple of these Databricks notebooks. Okay, so this first one just gives kind of an introduction to Spark and distributed data analysis. If you are not familiar with Databricks specifically, but you are familiar perhaps with like a Jupyter notebook, a Databricks notebook is very similar in the way that it is structured. It consists of cells. You can have markdown cells for containing like formatted text and images and things of that nature, as well as executable code cells where we can demonstrate actual code. Okay. So this lessons folder that students have access to, they have read access, but they are not able to run the code or edit any of the contents of these notebooks. But they are able to copy it to their own workspaces, and I encourage them to do that so that they will just have their own copy of the lessons that they can update and experiment with and things of that nature. So that's one of the first things they'll do in the course is copy that lessons folder over. Each student will have their own user directory. As an instructor, I'm able to see all of these, every student's directory, but students will only have access to their own directory. So within a particular directory, students are going to create a number of folders. A folder for their homework assignments. They're going to copy that lessons folder over. They're going to have a folder for their projects that they complete in the class. And then also I encourage them to create a sandbox folder just to contain any notebooks that they want for their own personal use, for their own exploration and experimentation. But that's totally for them to use in any way that they would like. The homework folder and projects folders contain Jupyter or contain Databricks notebooks that like I will grade. To show you a quick example of that. So here I have just a hypothetical like homework directory with a homework assignment for a student. This has say 6 problems with some code provided. The way that I set the homework assignments up is I will post a PDF on Canvas that contains instructions for what the student is intended to accomplish within the notebook. But then the student will actually create the notebook in Databricks and then create the content from scratch. And so, as I said, these are all markdown cells separating sort of the code required for each project or each problem. When a student completes a homework assignment, I ask them to export an HTML version of the notebook and then upload that to Canvas, just so that I have an official record of the homework submission on Canvas. And then also so that I can compare like the official submission with the notebook when I come back to grade it later. But then any grading I do, if there's any kind of feedback I need to give, I typically do that within the notebook itself. So for example, if I was grading homework 1 for a student and maybe they didn't get a perfect score and I needed to make some comments. So I would clone it and then just give it a name, homework 1 graded. And then within that, like say there was an issue with this first assignment or this first problem. So I would just drop in a markdown cell, or I would create a cell, turn it into a markdown cell, and then just add a little bit of commentary about, like I'd put some bold letters just to kind of get their attention and add some comments about like what the error is. And then if need be, I'll add in some pre-formatted text to demonstrate like the correct solution. So I think that gives you kind of a general overview of how I run the course. I guess I'll mention during office hours, I typically try to do 1 or 2 hours of live office hours each week. And in those, I will simply share my workspace. I'll create a notebook and then share it. And then I'll, demonstrate my solutions and examples kind of live in that office hour setting. Another thing that I find really handy, since I have access to the students' homework notebooks, if they need help during office hours or outside of office hours, I can go directly into their assignment and we can both edit that in real time, or I can kind of sort of coach them through a problem, ask them kind of leading questions and things like that. That is, I find, especially in a sort of a distance learning format, having that ability to both the student and I to be looking at the code at the same time and me giving them feedback is sort of indispensable. Like I find it very challenging to communicate and help students kind of perform problem solving relating to like code and technical issues through like email. And so having access to that notebook in real time is terrific. Okay, so let me see. I think that is largely everything I have had to cover. If you have any questions, I'll happily take those at the end. Okay. Thank you.
Thank you, Robbie. There was one question about adding users to Databricks Community Edition, just for the sake of the audience. One of the nice things about the presenters today is all of them are using Databricks Premium Enterprise accounts, which allows the full functionality of Databricks. Community Edition is limited to 3 or 4 users, so you can't set up one notebook and then add 50 students to it, or I guess the vice versa. So I'll put my email address in the Q&A. If you're interested in going beyond Community Edition, it requires a one-on-one conversation to set up the architecture. But once you're there, everything that Robbie mentioned is easy to put together. So I don't want to take any more time, but we can cover that more in the Q&A, but I just wanted to mention the difference. And if you look at 300 schools, 270 of them are going to be using Community Edition, and usually 10% of the schools in the program are actually using something more advanced. And basically the conversation about using more advanced is just connecting Databricks to your cloud provider. And in this case, it's, I think for all 3, it's AWS. So, all right, I'll stop talking. I will try, I guess, next on the list, turn it over to Su-Hong. Thank you.
Okay, so thank you, Robbie and Karen, to setting this up. And so I'm going to share my experience incorporating Databricks into my teaching and also student research. So I'm going to share my screen. So can you see?
Yep, looks good.
Yeah, so basically this is what I'm going to cover today. A little introduction about my background. I'm going to talk about how I use Databricks in my big data analytics course, and also data science capstone course. I'm going to discuss like some of the student research project using Databricks. So currently I'm in Bryant University, and I currently has been working for 24 years. This is my first job, my only job. And I teach different courses like database, NoSQL database, SAP, big data analytics, business analytics course. So my research interest in recent year has been focused on the social media and Twitter analytics, Internet of Things. And then we also in our school, and we have a data science program in undergraduate. we're trying to developing a master's degree in data science. So ability to process big data is a key skill set in our curriculum. I want to talk about how using the Databricks enable us to do that. So I'm going to skip this because remember like a few years ago and before I knew the Databricks, I'm really struggling teaching big data analytic course using Hadoop, like Apache or Teradata Aster, because a student needed to set up the software. It's very time consuming. So, and currently I believe in the big data analytic course, I want to say the entire course is run on enterprise Databricks. So just like Robbie, so Robbie talked about how plan that course. So I'm kind of follow the similar structure. If you look at the major content I covered here, I started with the introduction of what is the big data and talk about a little bit the distributed computing, Hadoop architecture, and then they cover Spark SQL, data frame, RDD, Spark streaming, machine learning. But a big chunk of this course, students also need to work on big data analytics project. Actually, because we have a collaboration with the company, and then we are working for students are working for real world project from our corporate partner. So, and then I want to show you basically how I deliver this using the Databricks configuration. And then for each course, usually I create like 2 clusters. So for each cluster, like I put 15 students on each cluster. So 15 students sharing a cluster, and then students can start to terminate a cluster, but they are not allowed to create a cluster because I'm afraid the student maybe they create like maybe 20 nodes, and it's going to quickly use all the credit I received from Rob about this course. And then so advantage of using Databricks is, compared to other, because it totally is cloud-based. And no need to install any software. You don't need to have supply any credit card, and you can create a class, and then can be within a few minutes. You can start a class and up and running. So, and then in another user for Databricks, I have used it in the data science capstone. So data science capstone is basically, and again, students need to work for a real company project. And then, but in this course, they are not just using Databricks. We encourage them to use any tool they have learned in their program. So sometimes they use Python, they use PySpark for the visualization. They may use Tableau, Power BI. If they want to create a network, they're using maybe Neo4j and Gauzy. So I see the Databricks. Actually, Databricks is just like a glue. Right, we as students can load the data in the Databricks, and then because Databricks has the capability to process a huge amount of data, so they do lots of pre-processing, cleaning, and then the data set becomes smaller. Some students may say, I'm just going to build a machine learning model using Python, but they still can use Databricks because Databricks, and you can also run the Python code. Sometimes they say they wanted to export, they run their analysis in Databricks, but they want to use the Power BI or Tableau to create a fancy dashboard. So the one thing I want to, there's some, like another perspective I said using Databricks is I have been like I have created additional workplace for the student. There are some students are working they're working with me on some research projects. So the one example I give you and really show the capability of a Databricks cluster is my Twitter research. So since the pandemic started in March 18, I have been collecting the tweets. And then currently I have about 978 TB tweets in JSON format I stored it in AWS storage. So right now I'm still collecting. So I just did a quick count yesterday. I'm looking how many tweets I have collected. Right now I have about 1.557 billion. So the question maybe I still like to ask is how long does it take to count like this really big data in Databricks? So, and if you look at the time here, I have my code here, like I imported all my data, I do a count. It took about 2 minutes to do a count. It's quite very, very impressive. It's kind of imagine, like, I think if you just have a local machine, it's just impossible to do. So another thing I want to show you is another example. And then I have all the tweets. I just want to see the number of tweet count by month, starting with March 2020 until last month, February 2022. So again, I'm doing like sophisticated, I'm grouping by year, month. I do a count. I also do an order. I need to sort them. So if you look at how much time it takes less than 1 minute to do. It's 53:47 seconds. So this is really like a powerful platform. I'm really grateful for Databricks to provide this opportunity for free, like for the university to use. Okay, so basically this is some outcome of a student research project. So this is some research they're working on. Some are looking at the psychological impact. There are another honor student working with me on fake news detection. And then there's one working on the emoji prediction, like based on the emoji because it represents emotion. So we use emoji to represent the emotion. Currently, 2 papers already accepted by conference. So they got an opportunity to present. They're going to introduce Databricks, how they use Databricks to process this huge amount of data set. So I just wanted to say, because I know that Ravi has a very structured course, they run everything on Databricks. So right now, I just want to compare with like a PySpark, like running PySpark on Databricks on Python. I understand today Python is still dominant language in data science. Again, it has much more library. And then I think it's a preferred tool for many people because people are familiar with using the Python and compared to the PySpark. But I think the better way to use is we can like integrate it about, right? I really mentioned if you have a big data set, it's much faster, more efficient. You use Databricks, use a cluster to pre-process your data, you clean the data. Once you clean the data, maybe your data set is not big anymore, right? I remove lots of unnecessary features. Maybe I'm just going to focus on a specific topic. This is what some of my students are doing. They use Databricks to do the pre-processing. So once data is cleaned, I'll say maybe I don't need like a sophisticated class. I can use the Python to build my machine learning model. Or they say I wanted to export the data and to visualize in other applications. So one thing really impressed me is just running the Python function on Databricks, because every time we run the Python code on Databricks, we're not utilizing cluster. We're just running the code on single node mode. But this is still much faster than running it like on a Jupyter notebook and using the Python code. So I want to show you an example. And because right now I'm doing like Python has a package called text-to-emotion. And then if you enter a tweet, a text is going to give you the emotion like fear, sad, surprised, happy, or angry. It shows you like what are the like rating for each one. And then again, this is very simple like function. You can just say you import this text to emotion, and you use it a function called get emotion. You import a text to show the emotion. And in Python, you can say I can just apply this to all the tweets. So I have collected some tweets related to climate change, about 1 million, and I'm trying to run on my machine. I have not a 36. I have a 64 gigabytes memory. I'm running on 1 million tweets. I'm trying to get the emotion. I have my machine open for 24 hours. It's still running. There's no results. So finally, I gave up. So I have decided to try to run in Databricks. So the Databricks allow you to create like they call the user-defined function. So it's the same. I'm define a Python function here by using like UDF, and then I'm just saying I'm going to convert it into a user-defined function in a PySpark so I can run it. So basically, I'm just going to like I have defined this. I'm running like this in my data set. I'm just apply this function to all the tweets. And did you see how long it take? 2.35 minutes. And then it returns the results from 1 million tweets because each emotion is a very sophisticated algorithm because it also consider like the emoji. It's going to look at do the pre-processing. It's quite impressive. Again, I just cannot do it using like my 64 gigabytes, like a local computer. So I think this is shown like for the people who love Python, and this is also pretty. I think I checked some document. Even while running Python code on Databricks, are saying we are not using the cluster. We're still just using this single node policy. Did some optimization. This is some way they make it in parallel, right? So be able to greatly and speed up the like processing. So basically, I just wanted to say, and this year in January, and then we got a new Databricks account. So they discontinued the new one. I think this one is a big improvement over the previous account. In the previous account, we can only create a workspace, one workspace. Within the workspace, we create a different cluster. But this time we can create a different workspace. Like for each course, I can create a separate workspace. So I create 3 workspaces, one for big data analytics course, and then another for my data science capstone, and then third one for my student project. So I just wanted to separate them because all my data, I usually I wanted to, in my big data analytics, to really demonstrate like power. We really need a distributed architecture to process big data. So I always store my data in AWS because all the projects students are working on is over we're looking at millions records, even for the company project. So they truly understand you just cannot use your laptop to do. You cannot just write the Python code. You do need to understand the PySpark, maybe even the big data technology be able to do that. So I think this is what I want. So I'm just looking at some of my future plan. I try to utilize the power of Databricks, and then I think Databricks has some pretty powerful package like we can run, I would say the graph analytics or deep learning, we can run the PyTorch, utilize the GPU capability. So this is something I'm exploring. I think in the future, I hope to be able to incorporate in my courses. And then I think another one I wanted to identify how, because I have lots of data, I have about 10 TB data stored in AWS. So how I can optimize the storage or access the big data. And it's also an area I'm trying to explore. Okay, so I think this is what I wanted to discuss. Any question?
There was one in the meetup, and I don't know if it was directed at you specifically, but it says, did you try using an S3 direct query compared to Databricks? So if that makes sense in the context of your work.
Yes, and now in AWS, AWS also has, I have used AWS like a cluster, what they call the elastic map reduce, EM or something. Before I know the Databricks, I did use like AWS cluster, but I found the Databricks is much easier to use because on cloud, I can just a few buttons, I can create a cluster. AWS is a little bit tricky to set up. I need to send the instruction to student. It's not like so. It's much like harder than using Databricks. Databricks for me is kind of a Swiss knife. A Swiss knife, you can teach Spark. You can teach R, you can teach Python, you can teach PySpark, you can teach PyTorch. So the any tool like you want, you can also like, it can run like you can use Databricks to write. So I think this is, for me, I think the company begin to realize like the power of Databricks. And now I have a student like took my course. They got the job because they know the Databricks, and then right now there's 3 students that are working as a data engineer, do all the pre-processing, I would say the data pre-processing, data cleaning. And so because I incorporate lots of data engineer, I think this is the most important part. All the data science project, 80% of the time is data cleaning, pre-processing, 20% of the time is to build a model. Okay, so I haven't used build, I don't know, build TL3. I can try, so I'm not familiar with this to build.
Okay, so we will continue to monitor the questions. Suhong has been just a delight to work with in the community, and just to learn every time she speaks on what she's teaching and the research that she's doing. I enjoy, yeah, my brain gets a little bigger. And do you, I guess for you and Robbie, do you have an idea of your AWS usage over the course of a semester in a particular context? For the audience, in general, people ask, okay, if I have Databricks and I'm running it against AWS, how much AWS do I use? I've been using, it averages $2,000 per semester for roughly 30 students, and maybe 10% of that is storage and 90% is compute. I don't know if that's a valid answer anymore. So
I wanted to say that for AWS, the storage wise is pretty cheap because I have 10 TB there. I'm not paying a lot. I want to say maybe 40 or 50, maybe $40 per month. I still think the major cost is still coming from the computing processing, because every time when you transfer the data from AWS to the Databricks, they charge you that. And then when you turn on the cluster, because you are using like the E2 like computing from AWS, they are charging you. So for me, I have like a student running pretty big data set. I don't think is, I don't know how much like a Databricks, because we got it for free. I really appreciate it. So the 2,000 for me is it's good enough, because because I say to save the I think to save the cost, instead you allow students to create a cluster. You can create like a cluster, and you assign some of the students share in one cluster. Like for my course, I only created 2 clusters. So they like assign half of my student to one and another half to another. So if you give each student, if they can create their own cluster, I think the cost will be much higher. So I guess, you know.
Okay. So I allow students to each have their own cluster, just because I'm concerned about things like students shutting down clusters or whatever while another student is using them. But I limit them in size, like a R5 large instances with 3 instances per 3 nodes per cluster. And my AWS costs are almost entirely compute, and they're about I think about $7, $6 to $7 per student per week.
Sorry, say that again, Robbie. I was typing and I didn't catch the details of that, the last sentence.
Oh, the costs in the versions of the course that I've taught are about $6 to $7 per student per week.
Sorry, Anadita teaches master students, so there may be, you know, a different cost component there. And just to say verbally, Scott Jensen, who teaches at San Jose State, he can transfer data for free on Community Edition using the AWS Oregon Data Center. And just a verbal question from Scott. Do you know how long the students are running the cluster each week?
I don't know off the top of my head. I have the clusters automatically time out after 30 minutes of non-use. They're using it throughout the week, I know, just here and there when they're engaging with the content. Usually you can see that the usage just spikes at the end of the week, like on Sunday when everybody's doing their, like working on their assignments. But I couldn't tell you off the top of my head anyway, like average usage per student per week, but I'm sure I could get that for you if you'd like.
So I wanted to say it all depends, like number of assignment you give to student. What I see is always before the due date, assignment is due, you see all the students get on the cluster. So the other time is really quiet.
Mm-hmm.
I'm sorry I had to look at my phone and do the math, but $7 per student per week is, that's in the ballpark of the $2,000 to $3,000 of AWS for an entire semester. So I'll stick with that number. Yeah, I don't know who I can't. Stephen McInerney, a graph of student usage versus hours before deadline. I'm pretty sure it's an exponential or hyperbolic curve, and as deadline approaches, it spikes up to infinity within the last 2 seconds. I think is how that curve would look.
Yeah, one thing I wanted to say is that students are working on a big project. Like they need to submit a report for company. Do you know AWS has a breakdown like a few months ago? Students are really panic because they cannot start their cluster. So I got tons of email asking, Professor Lee, the cluster is broke. What we should do? I said, why wait until the last moment to do your project? So I think it lasted for a few hours. AWS made an announcement on their website. This never happened in the past when I teach the course, but I could not remember which date they do have some problem.
And for Mr. McInerney, I am working on a dashboard that an internal dashboard that actually queries DBU usage for specific accounts. So when I get that dashboard put together, I can start to look at, and hide the specific information, but just look at macro trends in DBU usage, and I can solicit sort of, when is the end of the semester so that we can start to see, predictable, get some sort of idea on how to predict spikes in usage towards the end of the semester. Because I think probably 80% of the courses using Databricks Premium are on roughly the same semester schedule. Begins in mid-January and then ends, mid-May.
Yeah, I would say that the end of usually is at the end of the semester when their project is due. So in the beginning, I think they don't use it too much.
A quantified procrastination analytics is born. All right, I'm going to send you a t-shirt, sir, or a bunch of Databricks swag. No, I think I just got access to our internal Hive data store and access to example queries to do the calculations. So it will happen. Okay. Yeah, I think, and the one caution is if you're doing compute intensive things, there's a master's course at Berkeley that ran through about $25,000 of AWS credits in the course of a semester. So if you're hitting, GPU clusters or, things that are, TensorFlow or, deep learning, it's going to be different numbers, but it's nice that we're 12 months, we've had a fairly consistent ballpark of $2,000 to $3,000, 16 weeks, 30 students. So, all right. I think in interest of time, we'll pass it over to my wonderful colleague, Anandita.
Oh, hi, everyone. Thanks, Rob. Thanks, Karen. Wonderful to hear insights from Robbie and Shong. I may not be saying your name right, but great reinforcement of some of the things that I'm seeing as well. So love to chat with you offline as well. But anyway, so this is what my 2 cents is from my experience teaching Databricks at the Harvard Extension School. So that's the course, and the name is Data Engineering for Analytics to Solve Business Challenges. Who am I? Well, my day job is that of a solutions architect at Databricks, and I love Databricks. A lot of my clients as well for some of the same reasons that have been iterated before me. If data has arrived, it better be served. So, there's no point just consolidating the data. The compute is so well tuned, and we've got such a wonderful host of features on Databricks that it's actually joy to do anything, like any use case, any interesting innovation on it. My past experience has been in big data. So I come from Teradata and Think Big Analytics. And prior to that, I was at Nokia, which got acquired by Microsoft. I have a master's in computer science and a master's in liberal arts management as well. This is how we had set up the course. The prerequisites I had were for SQL, Python, Spark, and some big data. The class stats is somewhat like this. There are 2 TAs. It's a full semester. It's a fall class, or about 15 classes. And every week we have a class and we have a section. So there are 14 sections, except for the last one. About 40 students, and they are a mix of data scientists, data engineers, and analysts. And in terms of course logistics, most of these universities prefer Canvas for their main content, like decks and grading and all of that stuff. But I found Slack to be fantastic for collaboration. Like, for instance, we have Piazza and we have a few other options, but Slack was the most convenient to group people, to be able to set up different channels. And it's just the free version of Slack. So that wasn't paid at all. In terms of the book, I had recommended Spark the Definitive Guide, which students found a little dry, a little heavy, but that's almost like a Bible. Just a shameless plug here, I'm writing a book, Simplifying Data Engineering with Delta, which will be out this June. So I'm planning on using it this fall as well. And then the labs, every class has got a lab associated with it. And we have, of course, used Databricks on AWS because it's very convenient to do so. And we did get a good chunk of credit from AWS, like they gave us $10,000 credit. So we could use, apart from the DBU cost, we could leverage the AWS storage and any other compute that we need from any of their services as well. We had wanted attendance to be mandatory, but we realized that students are sometimes from different parts of the world, and it's actually very difficult for them to attend. So for some students, we had to be lenient and say that it's all right. You can watch the video recordings later. And the class is divided into 2 parts. The first half is a lecture and the second half is a lab. And the sections, of course, is recommended, but it's optional. It's mostly for Q&A sessions and help for assignments. And in addition, we have office hours as well. So this is an opportunity when somebody is shy and is not able to ask a question in front of everyone and does not want to feel bad about it. So this is like, ask me anything, and it should be okay to not know and learn from the ground up. So they can book 30-minute one-on-one slots through Calendly with the TAs or with me. In terms of lecture topics, again, the last lecture is the final project presentation. So it's a total of 14 lecture topics. We start off with the principles of data engineering, because without data engineering, you really can't do justice to analytics. Then there is modeling, ETL, batch and streaming. One thing I realized is it was too early to introduce streaming and people were struggling. So the next time I'm going to push streaming a little later. And then introducing the data lake, all kinds of data operations. So this is where we talk all about the CRUD and the merge and the deletes and the updates and all the asset transactions that Delta can support so nicely. operationalizing data pipelines. So this is around scheduling, around being able to recover the robustness in creating something ready for production. Then there is BI analytics and data visualization. So up to this point, we are trying to encourage the lakehouse paradigm. So up to this point, it is like primarily the data engineer persona. Now with the BI analytics and data visualization, we introduced Databricks SQL. And that is one of the reasons why we have to use the premium version. And that is what adds to the cost as well. So this is where the BI analyst comes in. The next couple of lectures are on ML focus, but still attacking the data engineering elements of it. Although I must say that quite a few students come from the data science and they really get caught up on the modeling aspect of it. And no matter how much you encourage them to keep that aside for a little while, it's difficult to motivate them to focus on the engineering aspects rather than the modeling aspects. So ML ops with ML flow, operationalizing the ML pipelines, then handling different data concerns. So these are atypical scenarios which you do not face every day, like data skew, a class imbalance, data masking, anonymization, like all of those things is covered here. And finally, unstructured data using text and a little bit of image. Specialized data stores, Sohang had mentioned about the graph analytics. So this is where we pick up a little on the other NoSQL databases and some amount of graph operations that can be done on Databricks directly. And then this is the DevOps persona who is interested in the CI/CD and the continuous improvement cycle, a little bit on disaster recovery. So it's the full gamut because we do want them to appreciate the lakehouse paradigm. In terms of how the course is assessed, so as you can see here, the weeks are numbered 1 through 15. The lecture topics are aligned as well. And so these are the assignments and these are the case studies and then the final project. So 3 big assignments, 3 case studies and final project along with the presentations. And of course, there's this whole grading policy. Everybody would like to take all the time to do it. So there has to be a penalty. And then, there will always be a little bit of a back and forth around somebody would say, oh, I don't want case studies. Maybe we should have more assignments. So I've had some of that in this course. So if you look at a day in the life of a student taking this course, as I mentioned, lecture in the first 5 or 10 minutes, I use a quiz-like structure to kind of make them remember or revise some of the concepts learned in the previous class. And they kind of enjoy it because it's done as a group activity. It's not like graded or anything. It's like they all pitch in and they found it fun, which is good. And any announcements or quick questions, and then an hour of lecture. The decks are all available on Canvas. They like the concept of guest lectures. So I have taken a lot of my colleagues. I thankfully have the ability to tap into them to come in and talk about an interesting topic for 30 minutes. So that way they can correlate the technical aspects or the theoretical aspects to an actual practical real world scenario. And when there is a guest lecture, of course, we squeeze it just a little. The second half is lab and the recordings are available for all. Section follows either the next day or the day after, and it's a fixed time, fixed format. Here they can go over anything. Usually it's question answer, concepts, going over the requirements of the assignment or solutions. We also use this time when there is a group project and they have to present. Office hours, again, as I mentioned, it's to resolve some team dynamics as well, which sometimes gets interesting. In terms of work space layout, Robbie had shared his screen and it's actually pretty similar to how he has it. I use repos to tap into a Git repository and pull in lessons and lectures. So in the beginning of the class, the slides will be available, but the lessons and the notebooks will be pushed to the home directory of each student, just as a convenience. So they find a new lesson. So if suppose this is the 4th class, then they will see lesson 4 and all the notebooks will get populated. The cluster templates are created, which means they can't create a new cluster, but they can always attach to the cluster that is meant for them and they can restart it. There are shared folders for group projects. And they can, here, suppose we do an assignment, the assignment is, the question is posted here, the solutions are posted afterwards. So this is a common area that they go to. And then within their individual home directories, they can't see each other's area, but as instructors and teaching staff, we can go in and help them out. And this is what it looks like. So from repos, we pull in the code. There are these assignments. There's a common area. There's extra credit. There's a final assignment and all the labs and a solution area as well. Another thing which I found very helpful was having periodic check-ins through survey forms. Like, so beginning of the class, I asked which data persona. There are a lot more questions, but I just picked up the ones which I felt were more interesting. And as you can see, a lot of them somehow came from the data scientist background, and here from the software engineering, BI analyst, and data engineer, it was a little more balanced. In terms of preferred language, Python does seem extremely popular, and that's not a surprise because they are mostly data scientists. Do you have any experience with Hadoop? Most of them didn't, but I was surprised that almost half of them had NoSQL experience, and there wasn't as much of a Spark experience coming into the course. Towards the end, we asked some other questions to gauge what they learned. Like, for instance, how comfortable are you using the Databricks platform? And most of the answers were tilted to the right-hand side. That means they got comfortable pretty quickly. This was asked like midterm. And, you know, in terms of guest lectures, sometimes people think that's a waste of time, but it was well appreciated. And the teaching staff, I think, stepped up quite a bit, basically helped them with their assignments is what this means, really. But one thing which surprised me is Harvard has this regular guidance around using case studies instead of just like here, this is how you use an API, and by the way, apply it here. Through case studies, you really have to do architecture. You have to understand what the problem is, what the challenge is, and how a company moved from generation 1 of the architecture to generation 2. And I had 3 case studies interspersed between the assignments. And I saw that some people had really strong views that case studies was not useful or did not think that it added value to them. So I have to do something about toning it down, maybe having 2 case studies or something, and converting one of them into an assignment. Although I personally believe that case studies is where they actually take an abstract problem and start to architect, build a whole before and after scenario, and think about all the different kind of trade-offs. But somehow this did not quite go as per my expectations. Now, if I were to summarize the good, bad, and ugly as to what worked and what didn't from my experience, then the good part is the student onboarding. I used a simple Terraform script, and that worked out quite well. The user directories were all very isolated. And the final project was a shared folder because they had to get together in groups to do it. The compute strategy for the labs, we had 4 shared clusters. Now, on retrospective, I'm thinking that maybe 2 shared clusters would have been enough. So for the 14 classes, having some isolation was necessary. Then for the assignments, we had auto scale clusters. So if all of them were to get on, it would scale up and scale down. I'm thinking like Robbie, I had about 30 minutes of idle timeout. I'm beginning to think that maybe I should make it 10 just to save on costs. And for SQL Analytics, I had a single shared endpoint. And because you have to have SQL Analytics, you have to have a premium subscription. So there was no other way to go about it. The class quizzes I thought was a hit because people just love that unknown element and the need to all jump in and who gets to answer first. Section and office hours were good. Slack was extremely effective. Guest lectures were appreciated. From the final project, there were 6 teams, and the winning team, it was to participate in a blog. In fact, I'll show you what they have finally come up with. It's almost ready to be published, just a little bit more push. And then I did 3 surveys throughout the course to keep getting the pulse as to whether we are going as per their expectations or where we could do better. In terms of the bad, I feel that the skill set is extremely varied. So you can't always please every person or every persona out there. So if you go too easy, the ones who are hotshots will say they are bored. If you go too high, then the ones who are just about starting up are just going to get lost so quickly that it's not even worth it. So, I chose to go the modest route. And I think it's okay to repeat some concepts. So the hotshots can afford to get just a tad bored. It's all right. As I mentioned, students resisted the use case study mode. So I need to either motivate them better or figure out how to tone it down some. The sections were not as well attended as I would have imagined, because they seemed to, either the timing was not working out, maybe it was too late in the evening. We'll have to figure that out. It was definitely inconvenient timing for some students from Asia and Germany. And like in every class, there will always be one or two team members who will have personality challenges. So some group dynamics had to be controlled and they were suboptimal. And, that's the usual drama that goes on. And it's so surprising that no matter which class, there will always be one or two people who will contribute to that entertainment. And the other thing is there is a certain subjectivity about the grading, because this is not like a math test that 2 + 2 is always 4. So depending on the person grading, there's some element of fairness across the graders, across different things, and that will come up in some way, some shape or the other. In terms of ugly, I would say towards the end, I realized that not everyone was coming up to speed the same way I would expect on PySpark. So PySpark, that means, was still a little bit of a challenge for one or two people. SQL Analytics requires premium. The security isolation requires premium. So the cost of the DBU was much higher. My AWS cost was hardly $2,000 or even a little less than that or around that. But my DBU costs were pretty high. Like, it surprised me. It started especially going bad in December, which is when their projects were getting beefier, and they spent almost a month on their final assignment, and the DBU costs were high. So coming up with good assignments to test the concepts and the working knowledge thoroughly is also a challenge. Like, we have so many of these assessment methods, but I still feel like there are gaps which are almost impossible to know how to test and what works and what doesn't work. So again, if you guys have some strategies on how you have tried to smoothen the curve and make sure that everybody gets something out of the course, and it's not just one end of the spectrum that benefits, I would love to learn from you. I did think of using the community edition, but the back and forth made me think that, no, it's all right. Let's just go with this and see how well we can optimize the next time. With that, I think that's all that I had. I could show you a few other things. Let's see. So that's the course, Data Engineering for Analytics to Solve Business Challenges. And I made it a point that we are not solving a tech for the sake of a tech. We are solving it because there's a real need to solve it. And this is the path to fastest, the fastest path to production. Any other system, any other platform, we would have spent like a couple of weeks just setting up the system, and all. Databricks is just turn on and zip, zap, zoom. I myself had done a course almost 10 years back on Hadoop. That's when I first learned big data, maybe in 2010. So it's more than 10 years. And I can tell you the experience was horrible. And that's why I was so excited to use Databricks to teach a big data and analytic course. The canvas was, again, very similar to what Robbie was showing, very similar look and feel. So all the grading and all the student resources, the course evaluations, and everything goes here. And then this is the Databricks workspace. So that's the course, and each student, like 40 of them, could actually collaborate and coexist and not be able to peek into each other when it is not. I thought that was fabulous. And this is the one of the team's final project. So they are their blog is Introduction to Analyzing Crypto Data Using Databricks. So this is where they pull in tweets around cryptocurrency. and they pull in Yahoo Finance data. They create a sentiment model and a pricing model. So they have the medallion architecture of bronze, silver, gold, and they have the different personas. So one of them is going to play the role of an architect. The other is going to be the data engineer, an ML practitioner, and a BI analyst, and they'll come together as a group and produce this final project. And they really did a good job. So around, doing some text analytics, around topic modeling, and then comparing different models out there, coming up with a correlation model, and then finally the Databricks SQL dashboard and 3 views of it, like, who are the main influencers, what's the stock movement, then what is the sentiment analysis, and then finally, what is the stock volatility, and what was their experience being on the platform, as opposed to doing it in a homegrown environment or setting it up from scratch on their own. So I'm very proud of their work, and hopefully in another couple of days, we should have that blog out.
Thank you so much. I think some of the variability in skill sets coming into the course is just a structural function of the program and the types of students that it attracts. So on the downside, there's a wider distribution of skills, but on the upside, when you look at delivering project results, different team members can bring different things to the table. And I think sitting in on and looking at some of the final projects in the presentations, it was just great to see the diversity of people and opinions and discussions. So
yeah, I had bullied Rob into coming and being one of the judges, final panelist in the project selection. So thanks again for that, Rob. Yes.
It was a privilege. It's so again, I will expect that same email at some point in the future on Andita.
Yes, once you have made the mistake of agreeing, that's it. You have to do it again and again. There's no escape anymore.
And Suhong is like, oh, Rob could help grade some of. So, no. Yeah. Anything for the presenters? Seriously. So, any questions or observations from Suhong and Robbie? And Karen, I apologize. I don't remember when we said we would end, but you are the arbiter of the time. So you say. I think maybe 5 minutes of questions. It feels good, but Karen's the boss.
Of course, yeah. I told everyone, our tech talks are more on the casual side. So if we go early or a little bit late, it's no problem. Okay.
So passing it over to either Suhong or Robbie, I'll go on mute, but if you have questions or observations for Anandita and her detailed exposition of the teaching experience.
I just wanted to say, it's as a project you share is really cool what a student did. Because sometimes my student also do the similar thing. I noticed for the topic modeling, they create a really nice visualization. Did they run that on Databricks for the visualization and topic modeling?
I didn't catch your question. Could you repeat that again, please, for topic modeling?
Yeah, for topic modeling, I noticed students create a very nice visualization.
Yes.
About the shell. So I know there's in the Python, there's a package can do that. So did they create that within the Databricks notebook?
Yes.
And Suhong, I'm laughing at myself because I remember, I believe it was you who asked how to get access to the machine learning part in the Databricks Premium notebook. There's 3 options. There's machine learning, there's data science and engineering, and then there's DB-SQL. The visualization is the DB-SQL option on that pull down menu. So yeah.
Some of those visualizations can be done in the notebook as well. So they did it in 3 different areas. So the data engineers didn't have much of a need for it, but the data scientists, the ML persons, they can do it. And then the Databricks SQL is it's such a cool tool. I mean, you write a query and you click the visualization and you click what kind of chart, and that's it, not a single line of code. And that's why people get so excited about the Databricks SQL, because it's very fast, very extremely productive.
Yes.
And Tableau and Power BI will always be prettier and better, but the Databricks visualizations, it's a more efficient way to just start to look at the data in a visual way.
Right. I want to say it's also very quick. You can quickly create a dashboard at the end, right? You can just organize. You can also add the parameter, right? If you want to have some filter. So I hope in the future for Databricks, the only thing I notice is really hard to change the displaying like a label. It's not so easy. Again, you can write the code, but like in other program language, much easier. If they add this function, maybe like more people is going
Actually, you are very correct. On the notebook side, it is harder to do it. It is much easier on the Databricks SQL side.
Oh, SQL.
You would be able to control the X label, the Y level. You can have like from the right hand side and the left hand side.
I need to go to check it out. I usually majorly use not the.
Absolutely. And the other good thing is all that visualization packages is also coming into the notebooks. So you will get a little bit of a similar look and feel, even on the, the data engineering and ML side of the house as well.
Yeah, great.
I really like that. I believe all of you mentioned that the data engineering is 80% and the machine learning and algorithms is 20%. And I think for students who are graduating into the workforce, knowing that ratio is important for them to understand the workplace when they get there. Even if they're, quote, data scientists, they will have to know the history and evolution of the source data as it goes from the source data to, and we call it medallions, but I just think of it as ETL pipelines. At some point, it gets to the point where they can actually use it in their modeling, but knowing the history of the data as it's been transformed from what it came in as to what's actually useful to them as data scientists is really, really important.
Yeah, I really think this is really strength of Databricks because I have lots of students working for like a corporate company. All the real world data is always messy. I can tell you the missing value. You need to do a lot of transformation, pre-processing. I could not find any tool is much better like than Databricks because students can pick languages that are comfortable, right? You can name Python and R. You can maybe directly use PySpark. You can automatically immediately create a visualization and then to see the pattern and the trend. So once this is done, but I believe Databricks, they also allow you to use Python. They call the color. Is this like you can directly transform Python code into you don't need to know the PySpark, right? It's a new
koalas. You're probably talking about koalas. Yeah. In fact, koalas has now been replaced. So koalas was like a little bit of a second-class citizen because it would just wrap it around pandas. So instead of saying as PD, you'll say as KS and do it. But now pandas also has become like a first-class citizen. As of last year, Data and AI Summit, they announced it. So if the students want to use pandas on big data on a Spark distributed cluster like Databricks, they can do that now.
Yeah, cool.
I didn't know that. That's very cool.
Question on the Q&A. How, if you have a student on Indita who didn't have any exposure to SQL or Python or PySpark, how did you address that problem? It's for me as a faculty member in a past life, it's the general question of you always have a wider distribution of student knowledge and skills than you would really, really want. How do you address that? But maybe this particular problem for your specific class.
Yeah, the prerequisites are a little hard. And because these are grad level students who are already part of a degree program, the chances of such a thing happening is low. what I would say is more probable is that they do not have enough of data handling experiences. So everybody had Python, like a little bit of Python and Spark is a given. But using those skills, how quickly can they translate it into the PySpark skills or the slightly more sophisticated SQL skills was the challenge. SQL, we gave them the first assignment as a data modeling assignment to get them warmed up. Like, this is the TPCH, understand that this is how benchmarking is done. And by the way, they should be, familiar to you. Now let's move little by little into the Spark world. And instead of being on a single node, see, you write just a little differently, and you can now parallelize it. And you're like, there's some of those examples that Sohang was showing was like incredible with, the number of the counting of the tweets or, finding the emotions and applying it as a UDF, and seeing is believing. So little by little, they get it. But as I mentioned, so, it's a little bit of your aptitude also. It does take a little while. So even if they didn't get it completely, by the end of the class, they have got enough data points and enough information to then plow and run with it. And within another semester or so of actually applying it themselves in different small projects, they will get the expertise. I have no doubt about that.
All right, I think we've got time for one more question. I was just scanning the LinkedIn list and the meetup Q&A. Anandita, also you covered AWS early in the semester. What assignments would you recommend to include in our courses? If that's one you can answer.
That's interesting, because the students were more afraid of how much of AWS expertise they really needed for the course. They weren't so intimidated with Python and SQL. And I kept telling them, you don't need to know anything about AWS. You just need to be on the AWS port, on the Databricks portal. And it's a drag and drop as you get sophisticated, and you can use the REST APIs and you can get all of that. But if you don't want to go into the AWS console, no big deal, because it's all abstracted away from you. So the cost of AWS that I mentioned was because every time you run Databricks, there's a DBU cost, which is the Databricks unit cost. And there is a little bit of like the cloud cost as well. So the cloud cost is taken care of by AWS, and the Databricks cost is taken care of by Rob. So I'm okay.
Yeah, fingers crossed. I used to have hair until I had to deal with IAM roles in AWS. Yeah. So Robbie, any closing comments from you or Sohang?
I guess I'll just say that I feel I was very lucky to find Databricks as I was designing this course. I started out with the community edition, but then switching over to the enterprise edition has been, just for me as an instructor, it's been terrific, but also I think the students have really appreciated it. I think it makes the course, the general experience of the course better, but also they really like getting experience with Databricks and kind of learning what it is, and sort of understanding that just by engaging in the course content, they're getting experience with a platform that is something marketable for them. And so I want to thank you, Rob and Karen, for providing that opportunity. It's really been great.
Well, thank you, Robbie. I'm not a marketing person. I really appreciate, however, what you and Sohang have said in terms of feedback. I do like Databricks, the company, because the founders came from academia, and just the fact that I exist, I get a salary, and this program exists is part of their commitment to saying, hey, we were PhD students at Berkeley in 2012, and now we're running a company, and let's do something and give back. It's self-serving for the company because it's, essentially long-term business development, but I do enjoy my job because I'm able to help get resources like this out to the teaching community. So anyway, we had a nice note. Jorge Peña Perez, I probably didn't say that correctly, but I want to thank all the presenters. Outstanding job presenting Databricks as a cloud-based platform to teach big data analytics. And all right, I got the name right. I could not agree more. Any questions, rob.reed@databricks.com, rob.reed@databricks.com. We will let Anandita get on with their evening in Boston, and Suhong and Robbie at Maryville, and Bryant and Karen, enjoy your camping this weekend. I really appreciate the attendees and the speakers, and Karen for I had to get on a bike from the city to where I am right now. There were a lot of headwinds. I was almost late to the kickoff. So thanks for your patience, everybody.
Thanks, Rob.
Yeah.
And thanks, Robbie and Andita and Suhong. Thank you again. And I hope everyone has a great rest of your day, evening. Take care.
Bye.